Good morning. Today we will correct together exercises 8 and 9, 59. Now let's start by number 8. Draw a triangle ABC such that BC equal 4 cm, CBA equal to 90 degree and BCA equal to 36 degrees. We start by drawing the segment BC by using our ruler starting from the 0. Here is a segment BC of length 4 cm. Now, CBA equal to 90 degree. This is CB and A should be somewhere here, such that a right angle is formed. We start from the 0 of the protractor to reach 90. So, this angle here is 90 degree. Now, BCA equal to 36. So, we put the protractor on the other extremity, starting from the 0, 10, 20, 30, and 6 dashes. It's 36 degrees. The point of intersection of these two rays here is A. Point A, and we draw here the triangle ABC. Now, draw the median segment AN. What's a median? It's a segment issued from the vertex, which is A here, to the midpoint of the opposite side. So, this is triangle ABC. I have to draw the median. First, I have to locate the midpoint of the opposite side, which is BC. Since BC is 4 cm, half of 4 is 2. So here at 2, I can plot point N. This is point N. So we draw the median segment AN. Now, what does N represent for BC? Since AN is a median, and as a definition, it's issued from a vertex to the midpoint of the opposite side, so N is the midpoint of segment BC, and we can use now that BN equal to NC. Now, the second part. The perpendicular bisector delta of BC. How can we draw perpendicular bisector? Either by compass or drawing a perpendicular at its midpoint. And since we said that N is the midpoint of BC, so directly here I can draw this line perpendicular to BC at its midpoint N. We name it delta as they asked. This perpendicular bisector cuts AC at M. This is line delta, the perpendicular bisector BC. It cuts AC at point M, so this is point M. Now, how to prove that MN is parallel to AB? What do we have as a given? We have that CBA equals to 90 degree, so AB is perpendicular to BC. And we also have delta or MN is perpendicular to BC. Why? It's perpendicular bisector, so it's perpendicular to BC at its midpoint. Okay, again, AB perpendicular to BC and MN perpendicular to BC. So clearly I can say that MN parallel to AB. Why? Because two lines perpendicular to the same third line are parallel to each other. It's a rule that we studied before. Now exercise 9. Draw a triangle EFG such that FG equals 6 cm, EFG equal 80 degrees, and EGF equal to 30 degrees. We start by drawing a segment by using our ruler starting from 0. Here, from 0 till 6, this is a segment FG. We put it in there, we put F and G at the extremities. Now, EFG equals to 80 degree. So, by using protractor, starting from 0, counting till 80, and here we draw the angle GFE. But up till now, we don't know exactly where's point E. Let's move to draw another angle and then find the intersection. We have EGF equal to 30 degrees. Starting from 0, 10, 20, and 30. We draw here a semiline, and the point of intersection of these two semilines is the point E. And that's our triangle EFG. What did I do? I erased the elongation, just that. Now the bisector of FEG. This is angle FEG. I don't know its measure, but I have to draw its bisector. I know that a bisector is a semiline that cuts the angle into two equal adjacent angles. How can we draw it? Either by using our compass or calculate FEG and then divide it by 2 and measure to draw the bisector. You can do it the way you prefer. I prefer here to find the angle. GAF equals how much? I know that the sum of angles in a triangle is 180, and I know the measure of these two angles. So FEG is 180 minus the measure of the known angles, which are 80 and 30. So 180 minus 110, which is 70 degrees. Now we know that the measure of angle FEG equals to 70 degrees. What's the half of 70? It's 35. So starting from the 0, 10, 20, 30, and 35. Here at this point I draw, and this is the bisector of angles FEG. Now this bisector cuts FG. It intersects with FG at this point. We name it at D, point D. Now calculate the angles GED, this angle, and GDE, this angle. How? I know that it's a bisector. Okay, and we calculated before FEG, it's 70 degrees. We know that the bisector cuts the angle into two equal adjacent angles. So GED equals to 70 over 2, which is 35 degrees. Okay? Here GED equals to DEF equal GEF over 2. Okay? Now how to find the measure of this angle? Again, I'll take into consideration DEG, a triangle. The sum of its angles is 180. I know two of its angles, 35 and 30. So GDE equals 180 minus 35 plus 30. It's 180 minus 65, which is 115. So here the measure of angle EDG or GDE equals to 115. Okay? Now, the height of the triangle DEG passing through E, the height of triangle DEG. This is DEG. I have to draw the height, but it's an obvious triangle, so the height is drawn outside the triangle. It's perpendicular to the line DG. Okay? It cuts DG at H. The point of intersection of the line DG with the height is H, so this is H at the foot of the perpendicular. Find the measure of the angles of triangle DEH. Here, since it's perpendicular through point H, so I can clearly say that EHD equals to 90 degrees. Now, what about EDH, this one? We calculated before that GDE equals to 115 here. But since these two angles are adjacent supplementary, so HDE equals 180 minus 115. It's 65 degree. Now I know the measure of two of its angles. So HED equal to 180 minus the known angles, which are 90 and 65. So 180 minus 155 equals to 25. Please copy the answers on your classwork copybook and don't hesitate to ask me if you have any question. Take care of yourselves. Thank you for your attention.